Hello everyone, and welcome to our presentation on the SCARA robot. Um, this project was developed as a part of the our subject called Computer Integrated Manufacturing. Myself is Syed Burhanuddin Hassani. I am presenting this project on the behalf of our team. So let's start this project. So let's start with the topic. The SCARA is stand for like a selective compliance and assembly robot arm. Is for like precision automation in assembly task. The content of this presentation is introduction and was the problem we are solving from this project, and the modeling and the assembly how it was done, and the overall summary of the project. So let's start with the introduction. Yeah, in this project, we have designed almost like uh, the 23 parts. Usually, the SCARA robots, the robotic arm, especially the SCARA robot, are vital in the modern industrial automation for their speed, rigidity, and selective compliance, making them ideal for pick and place and material handling and the assembly tasks. These robots are widely used in the pharmaceuticals, automation industry, and electronic industry, like for small parts assembling and like handling the products. Traditionally, these SCARA designs often face challenges related to the manufacturability and ease of assembly, leading to the higher cost of the product and their time due to the overlooked design constraints. This project bridges design and the implementation by using the Fusion 360 for detailed 3D modeling. We have also done like CNC milling process planning for only one part of the whole project. It was like a base part, and we have also generated the G code and simulate the real world manufacturing. The gripper assembly is mainly optimized in this project. Like we have done some optimization on gripper assembly to reduce the fastener and the increase the modularity, like which reduces the like time from 6 minutes to like 2-3 minutes. Now, while responsibility distributing the work was distributed in the team, like for every like 5 members have done like design of four parts, and two of the members were responsible for the project report and the presentation, and one member was doing the CNC milling and generating the G code. So let's move on to the next step. What's the problem, background problem about which we are solving in this project? Like SCARA robots plays a vital role in automation due to their high speed and performance. As I have mentioned it, despite their advantages, SCARA systems face like challenges in mechanical design. They are not like up to the mark, when we compare to the speed or when we compare to the uh, time, the manufacturability and integration and the efficient assembly due to the complex part and geometry and the interfaces. Using the Autodesk 360, this project covers the entire design process from 3D modeling to simulation and manufacturing plan generation, leveraging the modern CAD and CAM tools. Right. The base part was selected. We selected the only the base part for the CNC milling to demonstrate like real world manufacturing. And while the gripper, as I told you, the gripper assembly was chosen for the DFA, like uh, design for assembly. Like we have implemented in the gripper to enhance its modularity and reduce the fasteners. This hands-on project equipped a student with their real-world skill in mechanical design, CNC programming, and designing optimization using the DFM design for manufacturing and design for assembly for the future-ready engineering practices. Let's move on to the next one. Um, yeah, about the modeling and the assembly. As I have told you, like we have selected like for 5 members to do the design, and the rest members do the presentation and CNC milling. So these are the six first six designs we have done it. It has like the base and the screw fastener. Let me show you in the Autodesk. These are the designs, like all the 23 parts, like base, arm, and the bolt cap, connector, the gears, and the gripper. The gripper is the gripper holder, and the main, and this is the full assembly. This full SCARA robot consists of like 23 parts. All the 23 parts are assembled to form this SCARA robot. Uh, let me. Yeah, this is the SCARA robot. After that, let's move on to the next slide. Like on the next slide, we have like listed all the equipment, all the parts of the SCARA robots. 23 parts. The final assembly looks like this, as I have shown you in the Autodesk Fusion only. For the base, we have selected the base part for the CNC, like a CNC milling process, and this is the G code which is created for the base part. After that, DFA analysis. After the DFA analysis for the gripper assembly. In this SCARA robot project, the gripper assembly includes three main components. One is the grip, the jaw or fingers that makes the contact with the object. The grip connector, the intermediary that links the grip to actuator and mechanism, and the grip holder, the whole frame of the housing which supports the grip position of the grip. This is the improvement we have done it in the gripper. Number of parts before the DFA design was like three main parts plus the five fasteners. So after redesigning it, the main parts was three, but the fastener were reduced from one or zero fasteners. The assembly time was like before it was like 6 minutes. We reduced it to like 2 to 3 minutes. Usually the tools required for this was like the screwdriver and alignment jig. Possibly with this our redesign, you don't require any tool. The interchangeability was none before the redesign. After that, it's like interchangeable. Reusability, it was like limited up to some extent you can use it, but after redesigning it, we can use it to like more extent. And then let's move on to the next one. All together, the summary of this is like, we have demonstrated the advanced CAD modeling and the robotic system assembly using the Autodesk Fusion 360. We developed a CNC milling process and the plans and the G code highlighting the modern manufacturing workflow. We applied the DFA and DFM and DFA principles to improve the modularity, reduce fasteners, and enhance the maintainability of the uh, project. The SCARA robot, which showcase the potential of SCARA robots in the industrial automation and integrated design approach. So SCARA robot molded with modular gripper system that were the key result of it. The whole point of this project was like to improve the uh, the accessibility of the gripper part. So we have done it. The DFA reduces the fastener count by like 30%. The base part CNC tool path was generated successfully. We improved the assembly as well as the efficiency and the part manufacturability of the whole SCARA robot. The team usually, as I told you, like we divided the team into like four parts. The CAD modeling in Fusion 360, that were another one team, and another team was like manufacturing the plan and CNC code, like for doing the CNC. Another one who has done the DFA, the design for the assembly, like who has done the major like redesigning of the gripper. That was another team, Team C, and the the member or like Team C, Team D was like doing the documentation and presentation. Altogether, these are the references we have taken from various sources for this project. And thank you uh, for this presentation, and thank you very much.